Right, lesson 75, writing the equation of a line and slope-intercept method of graphing. First thing we're going to talk about here is just horizontal and vertical lines. Horizontal and vertical lines. If I have an equation, simple equation, something like x equals 5. When I have only one variable in an equation, I can graph the shape of it just by going to, here's how I remember it. If this is x equals 5, I go on the x-axis, which is this one. I find 5. I know it needs to go through that point. So it makes a line, a vertical line, like this. All right, so that's x equals 5. So just a simple variable with a number. All right, let's say y equals -2. A simple variable with a number is just going to be a straight line that's either horizontal or vertical. So y equals -2, I go to the y-axis, I find -2 on the y-axis, I draw a line. All right, so y equals -2 is an equation like that. So that isn't anything new that we haven't learned before. All right, now when we have an equation that has two variables in it, then things are a little bit different. And so far, the way that we've learned to graph them was making a chart of values, okay? Which is the correct way to do it, but that's going to be, there are some equations as we get into equations that have a lot of fractions and things like that. That's a good question, because that was a mistake, I think. It should have been down here, shouldn't it? Anybody else notice that? That I graphed it in the wrong place? Did you notice that? So, you're correct. It should have been down there because it was y equals -2. All right, my mistake. All right, now the rest of the equations are, all the other equations we've graphed are ones that have two variables in them. All right. Now, what I've been teaching you to do is when you have an equation that has two variables in it, to first solve it for y. So in other words, if an equation, let me change this. If an equation is written and it is not solved for y, it is much easier if we solve the equation for y. So for example, this one. If I subtract x from both sides, and this is how we did it before, 2y equals 6 minus x, divide by 2, divide by 2, divide by 2. One thing we're going to have to get used to, though, is we're going to rewrite this with the x term first. Okay. Every equation that we can graph, if it has two variables in it, here's what it can be written as. It can be written in this form, and that's what we want to get used to. I'm going to just write some other equations up here. We don't really need the graph. Get rid of the graph. All right, let's look at just some other equations. Y equals 7x minus 8. Y equals 4.2x plus 12. All right, every equation that has two variables in it, we can put it in this form. And you'll notice all of these here, there's a y equals some number plus some number. Y equals some number times x plus, and I could write that as plus -8 plus another number. Y equals some number times x plus some number. So we're trying to simplify this down. Okay, every single line that we could ever graph can look like that. So we're going to write a general equation. This is going to be very important. Y equals mx plus b. Y equals mx plus b. Where the m and the b are the two pieces that are required to figure out what the equation of a line is. So we're going to start off, we're going the other way now. Okay, before we were given an equation and we were told graph it. Now we're going to take a look at a graph and say, okay, here's what the graph is. Can I figure out what equation goes with the graph? All right. So this format is very important. And those two numbers actually have names. I'm going to write them up here. So let me rewrite that. Y equals mx plus b. So here's what m is. M is called our slope. B is called our y-intercept. Now, here where it says slope, here's what I'm going to write. All right, underneath slope, I'm going to write m equals rise over run. So all these terms right here are things that you're going to need to memorize. The format y equals mx plus b, we always want our equation to look like that. And then there are two pieces of information, two numbers that we will need to figure out. We'll need to figure out what m is and what b is, but there's an easy way to figure them out. And if we know what slope is and we know what y-intercept is, we can figure them out. And I'm going to explain what those two things are next. Let's start with y-intercept. That's the easy one. Y-intercept is where the line crosses the y-axis. Let me put some numbers on here. 1, 2, 3, 4, 5. So if you were looking at an equation and the equation looked like this, or the graph. So we looked at a graph and the graph looked like that. And we were trying to figure out what its equation was. This number right here, this b, is really easy to find because it's the y-intercept. That means where does this graph cross the y-axis? Where does it cross the y-axis? Right there. At the point 3. So the y-intercept of this equation is 3. That means this equation, this graph, if I want to write the equation of that graph, for sure, guaranteed, it's going to have a plus 3 at the end because that's where the line crosses the y-axis. That's the y-intercept. So I can fill in, instead of writing a b there, I can say, you know what, I know what b is. Because it crosses at 3, so instead of a b, I'm going to write a 3. That's my y-intercept. Tyson. Yeah. All right. Next. Let me write a different equation here. So if I write a different, or if I show a different graph, let me just draw another graph. Okay? So what if my graph looked like this? Where does this graph cross the y-axis? Anybody? At 5. So I know for sure that when I write the equation for this, I'm going to write mx plus 5 because it crosses at 5. So that last number is always really easy to find. Okay, it's just where it crosses the y-axis. Now, if I give you the equation instead, can you tell me where it crosses the y-axis? All right, let's do that. All right, y equals 4x minus 7. Where does this cross the y-axis? Anybody? Negative 7. So I know that the equation, when I graph this, I know it's going to cross at negative 7. Now here's what I don't know. I don't know, does it cross at negative 7 and go this direction? Does it cross at negative 7 and go this direction? Does it cross at negative 7 and go like this? Does it cross at negative 7 and go like this? All right, that's what we don't know. And that's what we're going to figure out with the slope. But right now, let's just worry about the y-intercept. Okay? So the y-intercept, that number is always going to tell us where it crosses the y-axis. So look at example 75.2 in your book on page 307. Find the y-intercept of the line shown. So the equation crosses the y-axis at a positive 5, so we know that its y-intercept is going to be 5. All right, so that's the first piece. First piece of this equation right there, the y-intercept. You look at the picture, where's it across the y-axis? Okay, now I know this number. All right, this number is called the slope. All right, and this number tells us how steep it is. Because just knowing where it crosses the y-axis is not enough information. Okay? Because, you know, does the line cross -7 like that? Does it cross -7 like this? This other number is going to tell us how steep the line is. That number right there. All right? Now let's go back to what the definition says about it. Definition of slope. It says rise over run. So rise is up and down. Okay? That's our y coordinate. You know, how much is it going up and down? Our run is left and right, which is our x-axis. So here's how we can measure how steep something is. Let's think about this. Like at your house, you probably have a staircase somewhere, right? Steep staircase, not steep staircase. All right. Let's say, you know, a ladder is kind of like a staircase except really steep. All right. We can measure, you know, what if you had a staircase like this at your house and a staircase like this? And you said, oh boy, that first staircase, that's a lot steeper. What does that mean? Can you define steeper? Can you mathematically tell me why this one is different than this one? Well, if I got out a ruler and I said, okay, on this staircase, if I go over 1 foot, if I measure over 1 foot, I then have to measure up 3 feet to get back to the staircase. That's pretty steep. What if on this staircase, I have to measure over, I don't know, 4 feet and then up 1 foot? Okay, that's a measure of how steep something is. Okay, I can do actual measurements and I can figure out if I go over 1, I then have to go up 3 to get back to the staircase. That's a pretty steep staircase. All right, this one, if I go over 4, I only have to go up 1 foot to be back on the staircase. All right, that one's not even nearly as steep. So there is a way with numbers to measure how steep a line is, and that's exactly what we're going to do on these problems. This number right here is taking the rise over the run. So let's look at these two staircases I put here. All right, this one has a slope of, let me write rise over run again. It rises 3 and it runs only 1. So the slope of this one is 3. 3 is a pretty steep slope. All right, how about the slope of this one? M equals rise over run. All right, the rise is only 1 foot. It only goes up 1 foot, but it goes over 4 feet. So the slope of this one is 1/4. That's a real easy way to look at these two things and say, wow, easy to see which one's steeper. The one with a slope of 3 is way steeper than the one with a slope of 1/4. So that's how we're going to determine slope on our lines. Okay? Now, let me find a couple example problems here. All right, now look at the bottom. Everybody look at the bottom page 307, where it shows positive and negative slopes. That's going to help you remember which ones are positive, which ones are negative. The little guy in the car. So when you read left to right. So let's think about the guy in the car is traveling left to right, just like we read. If going left to right, he's going uphill, that's a positive slope. If he's going downhill, that's a negative slope. All right, so we're going to do a bunch of examples of these because here's what we can now do. We can take a picture of a line and we can graph it. Actually, let's go the other way. We can take a graph of a line and we can write down the equation just from the picture. Okay, so here's our line. This is our line, and we want to know what equation would give us this line when we graph it. So first step, write down y equals mx plus b. So I have to find two pieces here. I'm going to find that piece and that piece. Okay. Well, my b, what is the b? What's the b called? What's the b called?
Y.
Y-intercept. So look at this drawing here and think, okay, where's this cross the y-axis? Where's it cross the y-axis? 2. There we go. Half the battle all done. Plus 2. Crosses the y-axis at 2. All right, now we need to figure out this. And to figure out that, we need to figure out how much up and over it goes. So we need to find some points here that we can use. Like, for example, this point. And we want to use ones that are on the grid. Okay? I'm looking for points where the line crosses on the grid, like that one right there. So if I look at those 2 points right there, and I think to myself, okay, I have to go over this many, and I need to go down this many to get back on the line. Well, how many did I go over? 1, 2, 3, 4, 5, 6. I went over 6. How many did I go down? I went down 2. Okay? Now I could have done it this way too. Wouldn't have been the same. 2, 6, same thing. Okay. So now we look back at, okay, here's our definition. M is rise over run. So how much did I rise? How much did I run? What's my rise? 2. What's my run? 6. 2 over 6. What's 2 over 6 reduced to? 1/3. Now the next question, is this slope positive or negative? It's negative. It's going downhill. So we have a negative slope. So I put that in here in place of m. Y equals negative 1/3 x plus 2. And that's my equation of this line. Logan.
How do you know where to find the rise and run at?
Wherever you want.
Oh.
That's not a good answer. But let me just show you. You have to, here's where you have to be careful of. You have to make sure you use points where the line is on the grid marks. Okay, so like right there, that's not a good point. It's not on the grid there. I want where the line is on the grid. Like there, that's a good point right there. That would be a good point there. And it won't matter. So let me just show you. Let's say somebody else in the class decided I want to use this point and this point. And they got a rise of 1 and a run of 3. Well, rise over run, 1 over 3, they got the same answer, right? What if somebody else said, I want to use this point and this point. So they're going to draw like this, and they're going to say, okay, we have a rise of 3, we have a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. So I put my rise over my run. What do you know? Reduces to 1/3 also. So you have to find points where we're on the grid. We want to be on the grid. All right? These points are all grid points. We have to be on those points where our line crosses those points. But it doesn't matter which ones you use because the slope of the line is the same no matter which ones you use. Let's do another one. Good problems. So let's say, how about, I gotta make sure I find ones that work well. How about this? How about that? All right, let's find the equation of that line. First step, let's write y equals mx plus b. Y equals mx plus b. All right, let's do the easy one first. B. B is the y-intercept, so where does it cross the y-axis? -3, so that means that number there is going to be -3. All right, that's always the easy one. All right, now we need to find our slope. So here's where we got to find points. Okay, that's a good point because it crosses on the axis there. All right. What other point? You're looking down this way. None of these are good points because they're not on the grid. Not until we get down to here is it on the grid. So if I use that point, which is 1, 2, 3, 4. All right, I went over 1, 2, 3, 4, 5, 6, 7. And then I had to go up 2. So my slope is rise over run. The question is it positive or negative? Positive or negative slope? Positive slope, we're going uphill, all right? So I leave that positive, 2 over 7 times x minus 3. That's the equation of my line, okay? All right. Now, this works the other way also. In fact, this is an easier way of graphing a line because we can take this and find the graph without having to make a chart. All right, so let's do one. So if I have a graph here, all right, and I said, all right, here's an equation. Y equals 2/3 x plus 4. Y equals 2/3 x plus 4. So before, what we would have done, we would have made a chart, we would have picked some values of x, we would have put them back into this, figure out what y goes with it, and it would have taken a lot more work. But now we can actually get the graph of it much quicker, because we know this. All right, so this number right here, that's my y-intercept, positive 4. So where is this going to cross the y-axis? Positive 4. So put a dot there. Put a dot at positive 4. Okay. This number is telling me my slope, my rise over my run. So it's positive. That means my line's going to be going up this direction because it's got a positive slope. So that means if I do it like stair steps, I go up 2 over 3, and then I put another dot there. Okay, let me see that. I went up 2, and then I went over 3. 2, 3, because this is rise over run. So I rose 2, and I ran 3. Now, I could keep doing that. I could rise 2 again, run 3, or I can even go down 2 over 3. It doesn't matter. I just have to keep with the pattern of, whoops, that one doesn't fit, does it? Down 2 over 3, down 2 over 3. I just got to stick with that pattern of 2, 3, 2, 3 as my steps. And I connect those with the line. And that's my equation of the line. I don't actually have to find the points. That'll show me where the graph of all the solutions is. Got it? It's good stuff. All right, let's do another one. All right, y equals negative 3/5 x plus 2. Negative 3/5 x plus 2. So first thing, let's figure out where it crosses the y-axis. Oh, where does it cross the y-axis? Anybody? Where does it cross the y-axis? Rollins. 2. Crosses the y-axis at 2. So I'm going to put a dot on 2. All right, now this I need to use as my rise over my run. Now, here's where we can write it a couple different ways. I can write it, I can put the negative sign with the 3, or I can put the negative sign with the 5. It will not matter. Right? Because if we're thinking of it as rise over run, when I see a negative 3, rising is going up, but negative is the opposite direction. So negative 3 means I need to go down 3. So I go down 3 because it's a negative 3. My run is 5, so I still go right. 1, 2, 3, 4, 5. That is the next point on my line. And really, 2 points is enough. Once I have 2 points, I can connect them, and I have my line. Okay, so that was a 5. So negative 3, positive 5 is the slope of the line. And that's what the line looks like. Now, what if somebody else decided this one? They're like, you know what? I want to use 3 over negative 5. Would they get the same answer? They actually would. Because a positive 3 says go up 3. But a negative 5 says go left 5. So positive 3, negative 5, guess what? I'm still on the same line. Okay? Still on the same line. So this is one of those things, as you get practice with it, you will be able to graph lines much faster than you did before, probably, once you get enough practice. Let's do another one here. One more graph. One more graph. All right. X minus 2y equals 4. All right, so this one is not written in the form that we learned. It's not written this way. I need it to be written this way. Well, how am I going to get it written that way? Well, I need to solve it for y. Now, so we can move the x over here. And I know sometimes when we did this before, we would just write it after. The only problem with that is I want it in this form so it lines up with this. So if I want it to line up with that, I want to put the x first and put the 4 second. That's a better way of writing it because then it matches up exactly with this form right here. We have the x first. So to get this solved for y, we would then need to divide everything by negative 2. Interesting. So if I divide everything by negative 2, I end up with y equals negative x divided by negative 2. That would be positive, and it would be a positive 1/2. Positive 4 divided by negative 2 is a negative 2, so that becomes a negative 2. Now it's in the form that I need. Okay? I've got my slope, and I've got my y-intercept. So this number is telling me it crosses the y-axis at negative 2. This number is telling me rise over run. Rise 1, run 2. Rise 1, so I go up 1, and then I run 2. So that tells me how steep my line is. I connect those points, my ruler, and there's my line.